Alright, hi, Trig Kids. So, partial fractions. There's type 1 and there's type 2 that we know about, and I would say all of partial fractions are type 2 fun, if you know what that is. So my husband, who's right over there, takes me on adventures sometimes that get a little bit unfun at the time, and that's how partial fractions are. But then later you look back and you're like, that was kind of fun, so that's partial fractions. So, a few hints for today, I think 5. So number 3, if you have problems 1 through 8, this is number 3. If you have problems 1 through 10, this will be number 5, and all the other ones will be 2 later. So just the form of the answer, you can have plus and negative, you can have plus and negative right back to back, or you can have minus. It takes all of them. I tried them out. So wherever you want to put that minus sign, if there's a minus sign in the fractions, you can put it wherever. It'll understand. Okay, next hint is number 5. Mine ended up looking like this, and it's kind of like, wait a minute, like how can I split it up? There's not really like two factors here. So we just need to start off by factoring the denominator. So we'll rewrite this as the top stays the top, and the bottom needs to get factored. So x times x is x squared. Things that multiply to negative 5, that add to negative 4 are negative 5 and positive 1. And then we're ready to split it up. So then we can do the a over x minus 5 plus b over x plus 1, and then do all the steps like G said in his video, and then there's no new surprises after that. Okay, the next hint is number 6. Same thing as number 5. You just need to factor it first. This one has a coefficient in front. A couple ways you can do it. You can guess and check. Maybe 3x times x will be 3x squared, and then you can try some things that multiply to 2 that will end up adding to negative 7 because the 3 gets in the way. Another way that you can do this that works every time is you can multiply the first and the last coefficient. So 3 times 2 is 6. And put it in the top of an x. You might remember this from Algebra 1, or Algebra 2, I mean, and Algebra 1. And then the middle term, negative 7, goes in here. We need things that multiply to 6 and add to negative 7. So I'm thinking negative 6 and negative 1 will do that. So these can't jump straight into factors. We're going to use those to split up the middle term and then factor by grouping. So the first term is still there, and the last term is still there. But instead of negative 7x, we're going to have negative 6x and negative 1x. So those are the same as negative 7x, we just split them up. It's kind of like mini partial fractions without the fractions part. Now factor by grouping means what can come out of the first two terms, like the biggest thing possible. So 3x can come out of both of them when we're left with x minus 2. And then we want this one to be x minus 2, so we want to dream something that can go in here to make it work. So I know negative 1 times x is negative 1x. And it also has to work here. So negative 1 times negative 2 is positive 2. So one of our factors is x minus 2. The other factor is 3x minus 1. Maybe if you guessed and checked, you came up with the same thing. Now I'm copying down that 3 from the very top, and you're ready to start. So it'll be like a over x minus 2, and b over 3x minus 1, and then do all the steps. Yada yada, you got it. Okay, 7. It's long. I'm going to do it with you. So here is mine. So there's 3 different things on the bottom. So when we split it up, we'll have something over x, and something over x plus 2, and something over x plus 3. And so then we'll do the next step, which is multiply both sides of the equal sign by the least common denominator, which is x times x plus 2 times x plus 3. Ooh, running out of space already. X plus 2 times x plus 3. And when we do that, all of this is on the top and all of that's on the bottom. So those just totally cancel. And then these ones are going to part cancel each time. And so this x on the bottom is going to cancel with that x on the top. But just on this fraction. So what I'm going to do is actually write all of this out, and then I'll be back because I think it might help just to see it once. Okay, so I distributed this red stuff to each of the 3 fractions and then just wrote it out. And then I rewrote this without the top or the bottom, so now it just has the old numerator, the old top. So this x is going to cancel with this x, and maybe I'll give it a scribble so it doesn't still look like x's. And then this x plus 2 will cancel with that x plus 2. And this x plus 3 will cancel with that x plus 3. And what we kind of have left is a times these two things plus b times these two things plus c times these two things. So they each kind of have left what they didn't have on the bottom before. And now what we're going to do is clean it all up. So I'm going to FOIL this, so x times z squared plus 3x plus 2x plus 6. All of that is still being times by a, so maybe let's combine some like terms and get plus 5x in the middle. Maybe you do that all in one step. That's lovely. Whoops. And we can distribute that a out. And basically, I'm going to do that same kind of a step to these others as well, and I'll be right back. Okay, we're getting there. So this side has an 8x squared. So I want to also have a something rather x squared over on this side. So the ax squared and the bx squared and the cx squared all have an x squared in common. We can take it out. We can take it out in the front, or we can take it out in the back, either one. But there's an a and a b and a c. They all had pluses in front of them. So those are the x squared terms. And now we want something rather x. So let's leave space and say, okay, give me all the x terms. 5ax positive and 3bx and 2cx. So 5ax and 3bx positive and 2cx. And then the only thing left over is a6 or 6a. So you could have these in whatever order you want. Okay, now we can equate the like parts. So I think I'm going to change some colors here. So instead of 8x squared, we have a plus b plus c x squared. So that means 8 is a plus b plus c. Or maybe we could even say a plus b plus c equals 8. The other way around. Either way, both are good. The 11x is going to be the 5a plus 3b plus 2c x. So 5a plus 3b plus 2c equals 11. Okay, and then the last thing is constant 6 equals a6. And so that is kind of its own thing. We could say 6a equals 6. And I wrote them like this in case you want to use the RF. So if you want to use the RF, you're going to think, okay, that's 1a, 1b, and 1c equaling 8. So in your matrix, you would have that as your first row. And then 5a, 3b, 2c is 11, 6a, 0b, 0c, and 6. So if you put it all in your calculator and you do RF, that works. Or maybe you're like, oh man, 6a equals 6, I'm just going to have at this. And then you're like solving for a, and then you put in the a's there, and then you only have b's and c's in two equations and use substitution or elimination to solve those. Great. But when you get it all down, you should have 3 letters, A, B, and C. And those letters will be these letters. So when you go ahead and type in your answer, you're like, okay, A is 1. So, because we found out there. So 1 over x plus whatever B is over x plus 2 plus whatever C is over x plus 3. One more hint. Okay, number 8 is just like number 7, except the very first step. So we're going to do that one together. The bottom doesn't have factors yet. So we want to see if we can factor this. The first thing to look for is a GCF. They do have something in common between both of them. So let's take out an x from both of them. Then we're left with x squared minus 1. And actually, this can factor even more, x squared minus 1. This is a perfect square, x times x. This is a perfect square, 1 times 1. And it's a difference of 2 squares. And so when we go to factor it, difference of 2 squares, so this one just copies down. We say x times itself is x squared, 1 to itself is 1. 1's a plus, 1's a minus. So if you factor out that denominator, it's ready to rock, just like problem number 7 started out. It'll be a little long. Good luck. Type 2 fun. Okay. Bye. See you next time. Last one.